Hey Amanda, I wanted to go through these two variation problems with you. So this first one says the intensity of a light varies inversely as the square of the distance from the light bulb. Suppose I is 490 when the distance is 7. How much farther would a point be where the intensity is 160? So when it says inverse variation, remember it's going to be division, and so it says I varies. We're going to always have this constant on top, and then we're going to divide inverse of the square of the distance. So it's not just going to be d, it's going to be d squared here. Okay? And now in here, take a look. Let's see if I can highlight these. You see it says I is 490 when d is 7. That's not a very good highlighter. How about this one? I is 490 when d is 7. So they're going to give us values of I and d because we're going to need to solve for k now. So we know that I is 490 when d is equal to 7. So let's plug those into this, and it's going to be instead of I, we're going to have 490 is equal to k. We don't know that value yet. That's what we're working to solve. And then on the bottom, we're going to have 7 squared. And you can see that 7 squared, this is going to be 490 equals k over 49. And then what do we do to get k by itself? We're going to multiply both sides by 49. So we're going to have 490 times 49. So we times both sides by 49 here. And that makes these cancel out, and we end up with 24,010 is equal to k. So now that we have k, let's take a look, and now it says how much farther would it be to a point where the intensity is 160? So how much further would it be? Well, we know k now, and here they tell us the intensity is 160. So let's plug those in. We're going to plug 160 in for I. We're just going to take this equation, and where we see I, we're going to put 160 equals, sorry, that's definitely a 0. K is 24010, and then we don't know the distance, so we just put that d squared in there, and that's what we're going to be solving for. So now we're going to just, I'm going to go ahead and we're just going to cross multiply here. 160 times d squared is 160 d squared, and then 1 times 2,410 is just 2,410. Oops. Now we divide both sides by 160, divide this side by 160, and we get d squared is equal to, when we divide that by 160, we get 150.0625. And now we're going to take the square root of both sides because we got to get that d by itself. So to get rid of the squared, we square root both sides. And now I'm going to take the square root of my answer, and I get d is equal to 12.25, right? Now 12.25 is not the answer. I would never do anything this tricky on the test, but do you see where it says how much farther? So where were we at before? We were at 7 meters, right? So to find out how much further, we're going to take the difference between 12.25 and 7. And so to find how much further it would be, it's going to be 12.25 minus 7. So our final answer is going to be 5.25. So it's going to be 5.25 meters further. Yeah, and that's kind of tricky, but as long as you can get to the point where we can get to D, that's probably what I would ask you on a midterm or something like that. So, all right, let's go down here and take a look at this next one. This one is a little bit more straightforward. We didn't have to do this little further thing. So it says a pitcher's earned run average, E, varies directly as the number of runs earned, R, and inversely as the innings pitched, I. So here we're going to have 3 letters as well as our K. So let's try to set up our equation. It says E varies. Remember, direct is we multiply by the k, so directly as r. And it also says inversely to I, so then we divide by I. So I'm going to read this one more time. It says a pitcher's earned run average, E, varies directly as R and inversely to I. And now when we take a look in here, we can see that it says a certain pitcher had an earned run average of 2.92, that's our E, giving up 85 runs, that's R, and 262 innings, that's I. So we know that E equals 2.92, R is equal to 85, and I is equal to 2.62. So now we're going to plug those numbers in to find K. That's kind of our first step in all of these. So we get 2.92 is equal to K. And then where I see that R, we're going to put 85. And then I is going to be 262. Now I'm going to get rid of the 262 by multiplying both in the denominator, by multiplying both sides by 262. 2.92 times 262 gives us, we end up with 765.04 equals, and then these cancel out here and we just have K times 85. Now to get K by itself, we're going to divide both sides by 85. And I get 9.00047. So we're just going to call K 9. Okay? If we have that many zeros in our decimal, I think we're good. So now that we have K, it says, let's go back up to the problem. It said, how many earned runs would the pitcher have given up if having pitched 292 innings at the same average? So let's see. So here we know I is going to be 292, right? So we know the number of innings is 292. And it said how many earned runs. So it's asking us to find R, right? And then what it's saying is if it had the same average, that means that the E is going to be the same value. So E is also going to be 2.92. So I'm sorry, the number of innings is 289, right? Because it says the number of inning pitches 289. It's going to be the same average, so the E stays the same. It's just asking us to find R, so let's plug that in. It's going to be 2.92. Again, we're taking this equation from over here. E is 2.92. We just found out that K was 9. We don't know what R is, so that stays R. And then we know our innings is 289. We're going to times both sides by 289 to get rid of that denominator. 2.92 times 289 gives us 843.88 equals 9R. Now we're going to divide both sides by 9. And we get 93.76444 equals R. Now it says round to the nearest whole number because we can't give up 0.7. So the number of runs that person would have given up would be 94.